Hey everyone, and welcome. Today we are gonna take a fresh look at teaching quadratic equations. We're talking about a new angle that helps our students move past just memorizing formulas and into some really deep analytical thinking. This is all about building real problem solvers. So let me ask you, does this look familiar? Your students, they can totally nail the formula. They can plug in the numbers, they can get the right answer. But when you ask them what it all means, where it actually shows up in the real world, you kind of get blank stares. You're not alone, I promise. It's a classic challenge. And that right there, that's the heart of it. It's this huge gap between the abstract formula on the page and, the actual path of a basketball arcing toward a hoop. Our goal today is to give you the tools to bridge that gap for good. And the main tool we're going to use is something called higher order thinking, or HOT for short. It's really just a framework that helps us shift our students from being, let's say, passive problem solvers to becoming active thinkers who can analyze, evaluate, and even create with the math they're learning. It's a total game changer. So, what does this actually look like in the classroom? Well, it all starts with a big shift in how we approach the concepts themselves. This chart really lays it all out, doesn't it? On one side, you have traditional formula learning. Memorize the steps, solve for x, get the one right answer. But on the other, you have conceptual thinking. It's about analyzing, evaluating, applying. We're basically moving from teaching a recipe to teaching our students how to be mathematical chefs. And that means our learning objectives get a serious upgrade. Your students won't just solve an equation anymore. No, they're going to analyze its form, they're going to apply the best method for the situation, evaluate how efficient it is, and, this is the really cool part, create their own real-world problems. Okay, so that's the big idea. Now for the fun part. Let's get into the practical playbook and see how you can start activating these concepts in your classroom, step by step. First things first, forget starting with the formula. Just don't do it. Start with a question that every single student can connect with. A simple hook like this gets them thinking, it taps into what they already know, and it immediately gives the math a purpose. And then, here comes the big reveal. You tell them that beautiful curve, that parabola, isn't just some random shape. It's a picture. It's a quadratic equation at work in the real world. And just like that, you've connected this complex formula to something they can see every day. Now, when it comes to a skill like factorization, instead of just giving them the rules, let them discover it. Give them the equation, and then ask some probing questions. Hold on, don't solve it yet. Just look at it. Can we break it into two pieces? Let them find the two numbers. Let them make the connection. They're not just memorizing a rule. They're uncovering a pattern for themselves. Okay, once they've got some of the basics, we open up the toolbox. We show them that there are a few ways to tackle these problems: factorization, the quadratic formula, and the graph method. But here's the key. We're not going to teach these in isolation. We're going to teach them so students can compare them. And this is where the real thinking happens. You follow up with these kinds of evaluative questions. You challenge them to think about strategy. Okay, which tool is right for this job? Why is one method way more efficient here? Are there times when factorization just completely falls apart? That's where deep understanding is forged. And the graph itself is telling a story. We teach them that the roots are just the spots where the curve hits the ground. The x-axis. The vertex, that's the highest point of the ball's flight. This opens up all sorts of great questions like, what if the graph never touches the x-axis? What does that mean? Or, hey, what happens to this curve if we change that a value? Grab a pencil and sketch it out. So we've activated the concepts, we've got them hooked. Now, let's look at some activities to take that analytical thinking even deeper. The discriminant, that b squared minus 4ac part of the formula. So often, this is just taught as a set of rules to memorize. Let's flip that. Let's present it as an investigative tool. So instead of telling them what a positive result means, we ask them, we let them explore why a negative discriminant means the solutions have kind of vanished from the graph. Here's a really fun group activity. I call it the methods showdown. You put students in groups, give every group the exact same problem, but assign each one a different tool to solve it. The magic happens when they come back together and compare not just their answers, but their process. It sparks these fantastic debates about which method was better and why. Another really powerful technique is error analysis. You find a worked out problem, but you sneak a mistake in there somewhere. Then you turn your students into detectives. Their job is to find the error. By analyzing every single step, they reinforce their own understanding in a huge way. And it's important to remember, all of these techniques, all these activities, they're all driving toward one ultimate goal: getting students to apply this stuff to the real world. That's when they finally see the true power of what they're learning. So give them a creative task, not just another problem where they solve for X. Something like this. Okay, you have this much fencing material and you need to design a rectangular garden with a specific area. Go figure out the dimensions. All of a sudden, that quadratic equation isn't just a formula, it's a tool for creation. Of course, if we're going to change how we teach, it only makes sense that we have to change how we assess, right? We need to start measuring what really matters. Your assessments need to reflect this new depth. You can start moving toward case studies, real application-based problems, and my personal favorite, questions that require written reasoning. Honestly, asking a student to explain why is one of the single best ways to find out if they truly get it. All of this really points to a shift in our role as teachers. We move from being the sage on the stage to more of a guide on the side. You become a think facilitator. Your main job is to constantly probe with why and how questions to push them toward their own discoveries. And if you take one thing away today, let it be this. Teaching with higher order thinking is all about making students think, compare, and apply, not just solve. We are developing the next generation of critical thinkers. So as we wrap up, I'll just leave you with this one question to think about. When you walk into your classroom tomorrow, what is the very first why question you're going to ask to spark that deeper thinking in your students?
Thanks so much for listening.